So the structural hazard, when a planned instruction cannot execute in the proper clock cycle because hardware does not support the combination of instruction, we have already discussed this. So for example, the memory, remember we talked about that if we keep the same memory for instruction and data, we can either fetch the instruction or read the data or write the data. One thing we can do at a time. Okay, so we have already addressed this issue with the help of separating the memories. So this is just an explanation, the visual explanation of this thing. So let's say this is a memory. We have the same memory. First look at here. This is the same memory, and then the register phase and the ALU, and then we read or write into the same memory, and then the register phase. Okay. So if we are running all the instructions in pipeline manner, you can see it here. Let's say this is time clock cycle. In this phase, we are reading the data from memory. LW instruction is reading data from memory. And at the same instant here, we are reading the instruction, this instruction from memory, whatever the instruction it is. So if the memory is same for instruction and data memory, this instruction cannot be executed. Agreed? So that is why we have already fixed this by separating instruction and data memories. So this is what we call the data hazards. There are also read hazards related to register, read and write, and I have already demonstrated that we write the data into register in the first half of the clock cycle and read the data into the register in the second half of the clock cycle. If we do not do this, we then have to halt the procedure here because we cannot execute this instruction at this instant of time. Okay, because this instruction is writing the data into register, and this instruction is reading the data from the register. And if it is writing into X1 and this instruction is reading X1, then it has to be read in the second half of the clock cycle. Yep.
So in that case, you have to leave a gap.
I have to leave a gap? Yeah, so if we cannot execute something, we have to either leave a gap here, or we do not execute any instruction in this particular time, and we wait for the instruction to complete it. So for example, this instruction wouldn't be at this point if it would be here. We cannot execute in any way, because if you are fetching the register X1, which is not yet written, we will be fetching the old value. Okay, so which will cause the problem in the execution of the program. Okay, that is called inserting a bubble, inserting a block where we do not want to execute the instruction. Okay. All right, so this is it for today. I can give you a couple of minutes to ask me any question related to your quiz, if you have any, and then we can start our quiz at 1 p.m. Meanwhile, you can please put your stuff here.